Okay, my name is Brandon Page, and I'm going to be explaining the space truss. The way this works is as a load is placed on top of the beam, it pushes down, which makes it act in a bending motion, bending downwards. This puts the top beam here in compression, distributing the load across the two bottom beams, which will be putting them in tension. The bracing here, you can see the member is actually in compression while putting tension on the connections or the joints, as well as the two here members, the two members to the side would be in tension, therefore putting the joints of each member to the side of the center one in compression. As you can see, as the truss starts to fail with more pressure, with the top being in compression and the bottom being in tension, you can actually see how the joint, even though that member would be, if connected, would be in compression, it's actually putting the joint at the top in tension, therefore pulling it away.
My name is Jamey Freeman. I'm going to talk to you a little bit about the space frame and give you guys an example of this great structure. This on the top, when I put some force on the top, it'll be in compression, putting the bottom in tension, and through these diagonals, share that load down to these 4 points throughout the system. See how this can carry the strength down to these points. This system is a 7.5 by 7.5 at the top, with the base being in tension at 4.5 by 4.5, with about 2.5 inches high in the diagonals. Now I can switch this over real quick, display the same area just through these small points. Carry the same load. This is beneficial for to be able to carry a larger load higher on a smaller elevation down in the ceiling. And I also wanted to show you what our original failure from our original space frame that we had created, and just to show the significance of these diagonal supports. I can do the same thing with this right here. By taking these diagonal supports out, you can see the bending. You put it on the other side, you can see the strength. Just by creating that same load, you see the bending, and that is our failure.
As you can see, after we removed the bricks, the side that did not contain the bracing is the side that failed, to show how important your subparts of your pyramid are to the actual space frame system.
Hi, this is Xing. We are taking video for our project for Professor Hines' class building great structures. We are going to make trusses and test how strong is our truss. And we have 3 team members, me, Jamey, and Brandon. I will talk about the planar truss. Okay. As you can see here, our planar truss, the horizontal members in the bottom is in tension, and the bracing here is in compression. So I will put 2 bricks on each side. to test how strong is our truss. Okay. Wow, look. And there you can see that we have bracing on this side, but we don't have bracing on this side. So when I push the brake here, we can notice that this side has some bending motions here. Okay, and I will put another brake on top of the truss, so you can see that the bending on this side is very obvious. That's how important is the bracing here. Our truss is very strong and it can sustain at least the weight of 3 brakes. Thank you.